Alright, so here we are with Unit 6, Lesson 8, and as you can see, this is more of a review. We've already discussed a couple of times endo and exothermic reactions. Before we get started, you're going to need to take out your reference tables because you're going to need to refer to reference table I. And table I gives you a bunch of reactions, and it tells you, in a way, whether those reactions are endo or exothermic based on the value for delta H and whether that value is positive or negative. So let's quickly run through. All chemical reactions either absorb or release energy, which means they are either exo or endothermic. When we did the unit on bonding, we also said that you needed to know whether the breaking of bonds or forming of bonds, I should say which one of those is exo and which one's endothermic. Well, when you break a bond, it must absorb energy. So it's an endothermic process, which means that heat is entering the reaction. It's being absorbed from the surroundings, which means that the surroundings get cooler or colder. At the bottom of this, you'll notice that there is an example of a reaction. What you should take note of is, first of all, the reactants are on the left side of the equation. Products are on the right side. Notice that heat is on the left side, so it's a reactant. That indicates that heat is being absorbed. So that tells you, that's one way of telling if the reaction is, that this reaction is endothermic. You can notice that here, you're starting out with a bromine molecule where the bromines are bonded. You're breaking the bond between the two, so you now have individual or single bromine atoms. That indicates a breaking of a bond, which is endothermic. When you're forming a bond, of course, that's going to be the opposite, exothermic, which means that heat is exiting the reaction, which means it's moving into the surroundings. So the temperature of the surroundings is going to go up. Here's another example. It's the opposite of what we just looked at. You have two individual or single N atoms, nitrogen atoms. You're now combining them. You're forming a bond. Notice the energy is on the right-hand side. Could have written heat, but if you see the word energy, it's the same thing. That's telling you it's exothermic. So what we had talked about, where does the heat go or come from when these reactions are involved? Well, it goes into the surroundings. So not only do you need to understand and be able to tell from a reaction if it's exo or endothermic, but once you've determined that, you also need to know, well, what does that do to the surroundings? Well, if a reaction gives off heat, that means the surroundings are going to get higher in temperature because the reaction is giving off that heat. So if you look at exothermic reactions, heat energy is leaving the reaction and it moves into the surroundings. So the surroundings will go up in temperature. Here's an example of one. So it's just a kind of a basic one. Reactants, products, you notice heat is on the right-hand side, so this is not anything new. I'm not going to spend a lot of time on this. For endothermic reactions, the heat leaves from the surroundings and moves into the reaction. So the surroundings are going to get colder. Here's an example of a sort of a generic endothermic reaction. Let's take a look at the video and see how long it is. Alright, so there's a pretty good example of an endothermic reaction. So the reaction that was occurring in the beaker was very endothermic, so it was absorbing heat from the surroundings. Now the surroundings was the water that was underneath the beaker. It absorbed heat from that water and it basically froze the water that was on the piece of wood. That's an example, a really good example of an endothermic reaction. Let's go on, and again, now you're going to be looking at reference table I. The term enthalpy is a definition that you should know. Enthalpy is the amount of heat released or absorbed in a reaction. It's generally written as delta H, the change in heat, so it can be negative or positive. You should know that, of course, and it says this at the bottom of table I, that exothermic reactions tend to have a negative delta H value, Endothermic reactions tend to have a positive delta H value, and that's what it says here. And that's all listed on table I. One of the things you have to be able to do is using table I, because sometimes they don't give you the equation, they ask you to use table I, be able to tell which reactions are exo and endothermic, and it's relatively simple. If you take a look at this portion of table I, this is the delta H. These are the reactions. There's more than these if you look on table I. These are the delta H values. So remember, negative delta H tells you that it's exothermic. So the first 1, 2, 3, 4, 5, 6. First 9 reactions are all exothermic, which means they give off heat, which means the surroundings are going to get warmer. If you look down here, these two here are endothermic because they have a positive delta H value. That tells you that the surroundings will get colder. So that's one of the things you have to be able to do. Two things. If it's exo or endothermic, and then what does that mean for the temperature of the surroundings? Now, we already did this. I'm not going to go through every single one of these. You can look on table I, and you can probably answer the questions yourself. I'm just going to quickly run through and give the answers so we can move on. I don't want to make this video too long. It's already almost 6.5 minutes. There are the answers. Okay, and that's the end of lesson number